Hi guys and welcome to IGCSE on Fingertips. This is a video specially made for day before the exam just for MCQ. If you have any questions or if you have any doubts in topics, you can look at a video that I have pinned here. Let's get started with the MCQs. What I'm going to do here is I'm going to try and explain the topic and then solve the MCQ, right? The first question reads, a student uses a spring gun to launch a steel ball with a constant horizontal velocity. He varies the height h of the gun and measures the horizontal displacement r of the ball when it hits the ground. Okay, so with an increase in height, right, what will happen if I increase the height? The ball is going to travel further and further and further, because even if its horizontal velocity is fixed, what will happen? It will have more time to travel, right? The distance r will depend on the time it gets to travel. The higher it is, the more time it gets to travel, right? Now, which graph shows the variation with height of the horizontal displacement? Here you have to understand that vertical displacement and horizontal displacement are different. They can be treated individually. So what will happen when the height is 0? The r is also 0. The ball immediately drops to the ground, right? So this cannot be your answer, right? Then they are not directly related, because r is directly proportional to v, but we know that s is equal to ut plus half at square, right? Or for this question, actually you should be looking at v square minus u square is equal to 2as. So s and v are related by square, or s is directly proportional to the square of v, right? So this cannot be your answer. Now we need to decide, if the when I increase the h, what happens to r? Sorry, does it go on increasing indefinitely, or what happens? So let's say for instance that I have started with a 10-meter height. Okay, for an easy understanding, what will happen? The ball, when thrown, it will take some time to fall to the ground. During that time, the ball travels horizontally as well. But when I go on increasing the height, right, the height, when I go on increasing the height, the distance that traveled also goes on increasing. But after a certain height, the ball will experience resistance, that is air resistance, air friction, right? Because of which it will not have this kind of graph, right? When height increases, this is not the relation. When height increases, the distance traveled then goes on slowly decreasing. So the option A is your answer. Then let's look at the next question. What do we have here? Okay, let's see. It says a sample of material is stretched by a tensile force to a point beyond its elastic limit. Okay, so somewhere along this here would be its elastic limit. The tensile force is then reduced to 0. Okay, then it is reduced again, brought down to its original 0 position. But because there is plastic deformation, this is the permanent extension in the wire. Okay, the graph of force against extension is shown. Which area represents the net work done on the sample? So if you look at this graph, right, x plus y and x plus y plus z is the total work done in stretching. But when you leave it, when you bring the force to 0, this z is given out in the form of heat, or it is given out in some other form. So the remaining work done in just net stretching is this much. You cannot gain it back. It is already used to produce this permanent deformation. So your answer should be x plus y, which is option B. Then we have there is a current from P to R. Okay, in the resistor network shown, the potential difference between P and Q is 3 volts. It is already labeled. The potential difference between Q and R is 6, again labeled. the potential difference between P and S is 5. Which row in the table is correct? Now, if the potential difference between these 2 points is 3, the potential difference between these 2 points should also be 3, right? Just a second. Let me see the diagram again. The potential difference between P and Q is 3, right? The potential difference here is 5. So, sorry, here this also should be 5. So, this should become 2, right? Then, if this is 6, then the total of these two should also be 6. So, this has to be 4. 2 plus 4 is 6. So, QS is equal to 2 and SR is equal to 4. So QS is equal to 2, SR is equal to 4. That is my first option and that is the answer I have, right? So potential difference between P and S should also be 5. I cannot have PS plus SQ is equal to 3 because this is already 5. Okay. Then we have a uniform bead, just a second, a uniform beam of mass 1.4 kilogram is pivoted at P as shown. The beam has a length of 0.6 meter and P is 0.20 meter from one end. Loads of 3 kilogram, 6 kilogram are suspended and 0.35 meter and 0.15 meter from the pivot as shown. What is the torque that must be applied to the beam in order to maintain an equilibrium? So torque is resultant moment. Okay, because torque is resultant moment. So let's say if the torque is in this direction, then I have to apply torque in equal magnitude but opposite direction, right? That will balance this beam. So let's try this question. So what do you have? You have center of beam of mass 1.4 kg. So there is 1.4 kilogram here. Now what should happen? This is pivot, right? So can I write 3.0 into 9.81, change it to force, multiplied by 0.35, it is 0.35 meter away from the pivot, plus this is also causing moment in same direction, so 1.4 into 9.81 into what will this distance be? This should be center, right? The beam is 0.6, this is 0.2, so this should be 0.10 meter. So 0.10, this minus 6 multiplied by 0.15 multiplied by 9.81 should be the available torque, right? This is known as tau, known as torque. Now let's calculate it. Oh, I forgot my calculator, just 1 second guys. Now let's calculate this. So we have 3 into 9.81 into 0.35 minus 1.4 into 9.81 into 0.10. That should have been plus. So 3.0 into 9.81 into 0.35 plus 1.4 into 9.81 into 0.1 minus 6 into 0.15 into 9.81. This is the resultant torque, 2.8449. What direction will this be? This is going to be in anti-clockwise direction. So I have to give my resultant torque in clockwise direction. Let's see what should be the torque. 0.10, okay, 2.8 Newton meter. Now if it was asked what direction should you give this resultant torque, it is anti-clockwise. Okay, this is clockwise and this is anti-clockwise, right? So actually it is anti-clockwise. What I should do, give a torque in clockwise direction. So that's your answer. Then what do we have? A diagram represents sphere underwater PQR and S are forces acting on the sphere due to pressure of the water. Okay, each force acts perpendicularly to the sphere surface. So let's say there was a window, I could see this is happening. This is the water surface. P and R act in opposite directions vertically. Okay, Q and S act in opposite direction horizontally. So Q should be equal to S because at a certain height inside any liquid the pressure is equal. Now what should happen? See, P should always be greater than R. Sorry, R should always be greater than P, right? Why? Because this is at a deeper point in the liquid compared to this surface of the sphere. So R should always be greater than P and Q should be equal to S. R should be greater, and that is your first option itself, right? Then we have, let's see what does this question say. A transverse wave travels along a rope. The graph shows the variation of the displacement of the particles in the rope with the distance along it at a particular instant. Okay. At which distance along the rope do the particles have maximum upwards velocity? So if this is displacement, right, this point will travel downwards. Now this point is going to travel upwards, this downwards. So how do I decide what point is going to travel in what direction? Look at its left hand side, right? If I look at its left hand side, whatever point it is, if it is above that point it is going to travel upwards, and if it is below it, it's going to travel downwards. This is again upwards and this is again downwards. Now if you imagine a pendulum, what will happen? It will have the maximum velocity at its equilibrium position. Here its velocity is decreasing, finally becomes zero at extreme position, again decreasing, zero at extreme position. So at equilibrium it has the maximum kinetic energy, least potential energy. So which points are traveling upwards? 0.5. The other point traveling upwards is 2.5, because this is a wave, both of them travel at equal velocity upwards, and that is the maximum velocity the particle can have at this point. At what distance along the rope do the particles have maximum upward velocity? 0.5 and 2.5. You have 0.5. I think there is no 2.5, so that is your answer. Then we have this question. Let me just, because I think this may not look proper when you are yes. Monochromatic light of wavelength lambda is incident on two narrow slits S1 and S2, a small distance apart. Series of bright and dark fringes are observed on a screen a long distance away from the slits. Okay, nth dark fringe from the central bright fringe is observed at point P on the screen. Which equation is correct for all positive values of n? Positive values. So what should happen if I want to have a dark fringe? It should be lambda by 2 into odd number, right? An odd number into lambda by 2. How do I express that? I can say that S2P travels longer than S1P, and this should be odd number, not n, let's say odd number multiplied by lambda by 2. How to find an odd number? I can say that odd number is 2n plus 1 or 2n minus 1, or I can take this 1 by 2 into lambda into 2n plus 1 or minus 1. Now because it says positive values, it's not including 0. So I must start with 2n minus 1 into 1 by 2 lambda, or in simple terms this can be written as n minus 1 by, sorry, because it says positive, n is not 0, and therefore yes. So this should be the term I am looking for. So S2P minus S1P should be equal to n minus 1 by 2 lambda, which is your option C, right? Okay, one thing I forgot. We are going to count today that what answers, what option we are getting, and at the end of the video we'll find this. So first is A, second is B, third is A, fourth is B, fifth is A, sixth is again A, seven is C. Let's start again. Okay, so we have two dogs are pulling the sledge on an icy track as shown. Okay, dog X pulls with a force of 200 Newton at an angle of 65° to the front edge of the sledge. The other one pulls at 120 at an angle of 45 what is the resultant force forward. So if I want to find resultant force forward, I'll have to find these two angles. 90 minus 65 is 25 and 90 minus 45 is 45. Okay, so the force due to this dog in this direction will be 120, and because this is the nearer angle, cos 45, this is 200, this is the nearer angle, cos 25. Addition of these two will give the total forward force, 200 cos 25 plus 120 cos 45, which gives me 266.11 Newton. Let's find the nearest answer. We have 80, 170 and 270 Newton should be your answer. Then we have sides of cube are measured with calipers. The measurement, the measured length of each side is 30.0 plus or minus 0.1 mm. The measurements are used to calculate the volume of a cube. Volume is equal to L cube, right? This is an uncertainty question. What percentage uncertainty is the calculated value of volume? Because volume is proportional to the cube, or volume is equal to cube of L cube. I'll write delta V by V into 100, which is percentage uncertainty in volume, is equal to 3 times of delta L by L. Delta L is uncertainty, L is the original value into 100, right? Percentage uncertainty. So basically this is nothing but percentage uncertainty in V is equal to 3 times of 0.1 upon 30.0 into 100. So I have 0.1 divided by 30 into 100 will give me 0.33 into 3 is 1, right? If you put all of this in your calculator, you get 1% as your answer. So 1% is your answer. Don't forget to multiply this 3, right? Then we have a simple question. See, I have not categorized question according to their chapter. Wherever I found a difficult question, I just took it and we are solving that. So it may not be according to topics. I hope that's okay. Which region of the electromagnetic spectrum includes waves with a frequency of 10 to the power 7 megahertz? See, there's a trick. 20 to the power 7 multiplier is already used and they are saying megahertz. So this is actually 10 to the power 7 plus 6, which is 10 to the power 13 hertz, right? Now we know V is equal to F lambda. They are asking about frequency. So velocities of light, right, of all the EM waves is equal to this. So into 10 to the power 13, I'll find F is equal to 3 into 10 to the power minus 5 in a range of minus 5, right? Visible spectrum is 10 to the power minus 4 to 10 to the power 7 or 10 to the power 6, something, right? Okay, so basically 3 into 10 to the power 5 outside the visible spectrum. So that should be infrared waves, radio waves, ultraviolet and X-rays. This is very high frequency. So if it is really high frequency, shorter wavelength, right? Oh, sorry. This is wavelength. This is not frequency. This is wavelength. Yes, I was thinking correct. This is, so 10 to the power minus 4 to 10 to the power minus 7 is the frequency. This is outside this and on the left hand side, right? Shorter waves. So just on left hand side is infrared. You need to remember the EM waves ranges. When you remember these ranges, you can easily guess which answer would be. But you have to keep on checking the frequency, wavelength, whatever it is given, and then calculate. Okay, so we have next question. A uniform resistance of wire XY length 100 centimeter is connected in series with a cell L. Another cell M is connected in series with resistors of resistance 5, 10 and 15 ohm. Okay, so it is balanced at 12.5 centimeter. 5 ohm gets balanced at 12.5. Okay, Connection position QR. So when I connect between QR, what should be the reading? When I connect between QS, what should be the reading? When I connect between PR, what should be the reading? So QR, QS and PR. So let's first find for QR. If 5 ohms has 12.5 centimeter as balance length, 10 ohms, right? QR is 10 ohm. That should have 25 centimeter as the balance length. So I'll write 25 centimeter here because this is a uniform resistance wire. It has equal resistance per unit length. So voltage drop in this region for 25 centimeter and for 10 ohm should be equal. That is where I get this logic. The basic formula is V1 upon V2 is equal to R1 upon R2. But because R is proportional to length, I can input it here and say that it is also equal to L1 upon L2, given that all the other conditions are same for the wire. Then I have QS. Q and S is 15 ohm. So if 5 is 12.5, 15 should be 37.5 centimeter. So I'll write 37.5 centimeter. Then I have PR. Just a second. QS is not 15, it is 25, right? It is 25. So 12.5 into 5 should be 62.5 here. Okay. And PR, that is 15, right? So 15 should be, as I already said, 37. So 62.5 centimeter and 37.5 centimeter. So let's find that answer. Not this, yes, 62.5, yes, and 37.5. So B is your answer. Then we have the velocity of an object changes with time as shown. Okay. Velocity changes, so there is acceleration. Whenever there is acceleration, what happens to the graph of displacement and time? See, whenever there is acceleration, the displacement graph cannot be a straight line. So wherever there is straight line, straight away that is not your answer. Okay. Now, what is happening? Velocity is decreasing. So even though the displacement may be increasing, the rate of change of displacement is getting lower and lower. And then it becomes negative. It tries to come back to the same position. But I believe it's not the same height. So is not coming back to the same position. But the graph is changing direction. If graph is changing direction, this cannot be your answer. And therefore, this is your answer. It is also logical here. See, what will happen till this point? The velocity goes on decreasing. So displacement is increasing, but at a lesser rate every passing second. And then it changes direction. So displacement becomes, the change becomes zero. So a horizontal point there, and then starts to decrease. Horizontal point, wow, not point, guys. Horizontal line you can draw to find the slope. Okay, then we have a projectile is launched at an angle to horizontal at time t is equal to 0. It travels over horizontal ground as shown. Assume air resistance is negligible. Which graph best shows the variation with time t of the speed of the projectile from where it is launched, right? So here it has velocity v, then at this point it has only horizontal velocity, and then let's say it also has vertical velocity, but at this point the vertical velocity is 0. It has horizontal velocity, and here the vertical velocity will be as much as the starting point because there is no air resistance, right? Okay, let's see. Speed is not constant, it is changing because the vertical velocity keeps on changing. So this is not your answer. Then we have, it becomes, no, it does not become 0, and I think this also does not become 0. So option C is your answer. The speed decreases but then starts coming back to its original value, right? Then we have this question. Okay, so question says an elastic collision occurs between two bodies x and y. It is an elastic collision. The mass of body x is m, the mass of body y is 4m. Body x travels at a speed v before collision and speed 3v by 5 in opposite direction after the collision. Body y is stationary before the collision. What is the kinetic energy of body y after collision? To find kinetic energy, I will need velocity of this body. Let's say it is x because v is already taken up here. Now, instead of finding the whole momentum, that the initial momentum is equal to final momentum, because question already says that it is elastic collision, you can use a small trick here, that you can say, first let me explain that velocity of approach should be equal to velocity of departure, right? If it is elastic collision, the total kinetic energy is constant, so you can take half mv square is equal to whatever, right? That is a little bit difficult way, or you can say velocity of approach is equal to velocity of departure. If the bodies are in opposite direction, this is opposite direction, right? Or they are in same direction. These are the two conditions that are there. If they are in opposite direction, just add the magnitude of velocity. That is the relative velocity of approach or departure. And you subtract if they are in the same direction, that is again your velocity of approach or departure. Let's quickly find that out. So velocity of approach is v plus 0, right? But velocity of departure is in opposite direction. So 3v by 5 plus x. Quickly finding x will give me, it is v minus 3v by 5, which is 2v by 5 is the value of your x. Now, simply kinetic energy is half m v square. So half into 4m into what is velocity? Velocity is 2v by 5 whole square. So you have 4v square upon 25 into 4 upon 2. This will give you 16v square upon 50. That is your kinetic energy of body Y after collision. Option C is your answer. Then we have next question. Okay, so this question is about waves, and this is an interesting question. I would say it's also a little bit difficult question. A string is fixed at one end and the other end is attached to a vibrator. Frequency of a vibrator is slowly increased from 0. A series of stationary waves is formed. Assume that for a stationary wave there is a node at point P. Okay. What are the first 5 wavelengths of the stationary wave that could be formed? So the first wave that could be formed, standing wave, that should look like this, right? So node, antinode and node. So the length should be equal to half of the wavelength, right? So the first wavelength is, they're asking wavelength, right? So lambda is equal to 2L. Then when the second standing wave forms, it looks something like this, right? So this is one full wave. So in the second situation, L is equal to lambda, or lambda is equal to L. Let's look at third situation, what happens. So this is how the wave looks like, the third harmonic, right? This is how it looks like. This is where L is equal to 3 by 2 lambda, or lambda is equal to 2 by 3 L. And then when you look at fourth harmonic, fourth standing wave, sorry, this should be something like this, right? So these are two waves, so length is equal to 2 times of lambda, or lambda is equal to L by 2. So lambda value is going on decreasing. So 2L, L, 3 by 2L and L by 2. Okay, 2L by 1 is 2L, 2L by 2 is L, 2 by 3L, okay, 2L by 4 is L by 2. So this is your answer. Let's check if this occurs anywhere else. This is incorrect here. This is incorrect here. This is incorrect here. Okay. This is incorrect here also. This is incorrect here. So only A is your answer. Then we have next question. It says diagram shows. Okay, let me try and okay. Clearly visible. Diagram shows a stationary wave at time t is equal to 0 that has been set up on a string fixed between point P and S. The nodes of stationary wave occur on a string at P, Q, R and S. So these will not move. These are nodes. Point X is moving down at time t is equal to 0. The points on the string vibrate with a period V and maximum amplitude 2. The displacement S is positive in upward direction. So this is having negative, this will have positive. Should have drawn through the node positive and then negative displacement, right? Which graph best shows the variation with T of displacement S of point Y? It should be negative, but it will not be as much as point X because it is very near to the node compared to X. X is somewhere around the midpoint. So what I'll say, it is lesser than S but in negative direction, right? So lesser than, not S, 2, right? But in negative direction. Only this sets because this is negative direction but equal to 2. This is positive, positive and equal to 2. So option A will be your. Then this next question we have, okay, should be visible. The diagram shows apparatus for the measurement of frequency of a sound wave. Sound of unknown frequency is reflected back from a metal plate. A microphone placed at a distance d from the metal plate detects the sound intensity. The minimum intensity is detected with d is equal to 12 and plate is moved further away from the microphone. Again minimum is detected at 15. So minimum is detected when there are nodes. So node, antinode and node. This distance is 3 centimeter. What the speed of wave in air is 336 meters per second. What is the frequency of sound? So its wavelength is, so lambda by 2 is 3 into 10 to the power minus 2 meter. I can say lambda is equal to 6 into 10 to the power minus 2 meter. We know that V is equal to F lambda. F is equal to V by lambda. This means that 336 upon 6 into 10 to the power minus 2 is equal to F. So 6 5s are 36, 6 are 36, goes up, 5600 hertz is your frequency, which is option C. Then we have, let's enlarge this question as well properly. Okay, I believe should be visible. A cylindrical iceberg of height h floats in seawater. The top of the iceberg is at height h above the surface of water. The density of ice is Pi and the density of seawater is Pw. What is the height h of iceberg above the seawater, small h? Okay, you have to find this small h. What logic will we use? First of all, because it floats, right? For this iceberg, the upthrust is equal to weight, correct? Otherwise it wouldn't float. And upthrust is also equal to the weight of water displaced, right? That is Archimedes principle. If I want to find weight of water displaced, which is your upthrust, okay, so weight of water is density of water multiplied by the volume of the iceberg multiplied by g, because this is nothing but mass of the water displaced, correct? So once I have all of this and I equate it with w, what is w? W is weight of the iceberg, and we will use, instead of m into g, we will take density into volume into g. Wherever you see buoyancy question, Archimedes principle question, you always use this method. Okay, look at densities. The difference is because of density. So what I'll say that weight of iceberg, which is density of iceberg multiplied by volume of the iceberg. This is submerged volume. Okay, so volume of the iceberg will be area into the capital height h into g. All of this will be equal to density of water multiplied by area of iceberg multiplied by the height of iceberg, that is submerged. So I can write this as into capital H minus small h into g, right? G can get cancelled, area is equal, the base area. So I can write density of iceberg upon density of water is equal to H minus H upon capital H here. Is anything else remaining? No. Let's see now what can be done. I can write that density of ice upon density of water, we have all the options visible, is equal to h upon h minus small h upon h, right? This will become 1. So density, and then I can change the sides, which will give me h upon h is equal to 1 minus density of iceberg upon density of water. So h is equal to capital H multiplied by 1 minus density of iceberg upon density of water. This is your answer, which is option A. Okay. Then next question we have. This is rather interesting question, right? We need to look at a few things here. A transverse wave in a medium has the waveform shown. Y is vertical displacement, x is horizontal distance. Okay. The speed of wave is 20 centimeters per second. A particle of medium oscillates vertically. Which graph of the vertical displacement y against time t represents the motion of the particle? So let's first find out how much time will it take for the particle to travel this 8 centimeter. We have distance upon time is equal to speed. So I want to find out time. Time is equal to distance upon speed, which will be 8 upon 20. This should be 4 by 10, which is 0.4 seconds. So two waves pass in 0. These are two waves, right? So two waves pass in 0.4 seconds. Now let's find out y should remain same, 1. Okay. One wave is passing in 0.2 seconds. So two waves if pass in 0.1 wave will pass in 0.2 seconds. I think A is our answer, but let's check. One wave passes in 4 seconds. This is incorrect. Then this is not a wave, this is corrected wave, right? There is no negative amplitude, so this is incorrect. The same thing is happening with here. So yes, A is your correct answer. Then we have this particular question where it says two cables are attached to a bracket and exert forces as shown. Okay. What are the magnitudes of horizontal and vertical component of the resultant of the two forces? Now guys, see, you have components a lot of times, right? Now as far as I understand, sometimes you get confused as to which component should you take. So simply remember it like this. So this is 6 Newton. I want to find horizontal components. So in this direction, right? What I'll do, I'll find the angle of this force to this component. If you can, most of the times you can. Because this is 90, this has to be 50, right? And this is already given 20. Wherever, okay, let's say this is your force F and this is the angle given as theta. The projection of force F on the angle, the line on which it is making angle is always equal to cos theta, the nearer one. The other one is sine theta. Okay. If nothing else, if you remember this much, it is enough to find out the parts of the force acting in horizontal and vertical direction. So this will be 6 and nearer angle, sorry, 6 cos 50, or for your knowledge you can also find out it is also equal to 6 sine 40. Both of these components are equal. Okay, but let's calculate this. So horizontal force is 6 cos 50 plus 15 cos 20. Okay, and the vertical force, components of vertical forces are in opposite direction. This is 15 sine 20, right? And this will be 6 sine 50. You can also write 6 cos 40. That will also be same. But this is what I have, and this will give me the answer. So I have 6 cos 50 plus 15 cos 20. This is 17.95. and I have, because this is obviously greater, I think 15 sine 20 minus 6 sine 50, right? This is 0.534035. Now let's find out, this is your horizontal and this is your vertical. Horizontal 17.95, okay, can be rounded to 18, so not your answer. 0.53 from the, okay, so C is your correct answer in this case. No. Then we have next question. A student wishes to determine density rho of lead. She measures the mass of and diameter of a small sphere of lead. Okay, mass is given, diameter is given. What is the best estimate of percentage uncertainty in her calculation of rho? For this, first to find out what is the formula to find rho from mass and diameter. I know that density is equal to mass upon volume. Because this is sphere, it will be 4 by 3 pi r cube. Okay, but they have given diameter. So what to do? See, simply remember that because r is equal to d by 2, and remembering from older question, can I write delta r by r into 100 is equal to delta d by d into 100, because they are linearly related, right? Power 1 power 1. So percentage uncertainty of diameter is percentage uncertainty of your radius as well. So it's okay. For uncertainty questions, you directly use the uncertainty of diameter. So I'll say delta rho by rho into 100 is equal to delta m by m into 100 plus 3 times, right? Because the power is 3, delta r by, or delta d by d into 100. See, you can remove 100 altogether from all sides because it is percentage and 100 is common and cancelled. So delta rho by rho is delta m by m. So 0.00, I'll input the values as well. 0.05 upon 0.506 plus 3 times of 0.02 upon 2.20. So I have 0.005 divided by 0.506 plus 3 into, oh, 3 multiplied by 0.02 upon 2.20. This will give me 0.037154. Okay, multiplied by 100 because I want to find it in percentage. So 3.7154 percentage, which will give me 3.7 percentage, not 37, 3.7 percentage. Then this question is about quantization of charges. Any charge has to be a whole number multiple of your fundamental charge, which is electron minus 1.6, just 1.6 into 10 to the power minus 19 coulomb. Okay, let's read the question now. An electrolyte, the electric current is carried by charged particles in solution. What is not a possible value for the charge on an ion in solution? Okay, whichever is not divisible by 1.6 is your answer. 16 threes are 48, so this can be a charge. 1.6 and 1.6 can be a charge. 16 twos are 32 can be a charge, and without calculation D should be your answer. But 4 is not divisible by 1.6, right? 4 ones are 4, 0.4 times, it is not whole number. So D is your answer. Then we have the graph. Okay. Yes. The graph shows how a physical quantity varies with time. Okay, what is happening to physical quantity? Decreases, becomes 0, decreases even further, and then becomes 0 again. Which event could be represented by graph? Acceleration of a firework rising to a maximum height and falling to the ground. In that case, what will happen? If it is acceleration, then for firework it is negative at the start, right? Becomes 0, and then because gravity acts downwards, so its acceleration is decreasing, and then reaches a maximum height and falls to ground. So goes on increasing. Okay, so this cannot be your answer. The direction is different. Acceleration of a skydiver leaving an aircraft. Okay, so his acceleration goes on decreasing, 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 reaches terminal velocity. Operating parachute. When he operates parachute, his velocity decreases further, right? So deceleration takes place suddenly and falling to ground. But what will happen? This will again become zero as he reaches terminal velocity again. So I think yes, B is the correct answer. But let's see the speed of javelin as it leaves an athlete's hand, falls and sinks into the ground. But there is no jerk like this, right? For the javelin. Speed of a high jump athlete leaving the ground, jumping over a bar and descending to the ground. That, see, the speed of a high jump athlete, it starts from a maximum value and goes like this, right? So that should also not be your answer. Option B is the correct answer, guys. Then we have, this is a rather easy question, but let's do this. A combined heat and power station generates electrical power and useful heat. The diagram shows input and output powers for a CHP station. Input power is so much. Wasted power clearly given as 60 megawatt. Useful heating power 160 and useful electrical 100. What is the efficiency of CHP? So efficiency should be output, which is 160 plus 100 upon input. Input is not given, but the total of these three must be input. Law of conservation of energy plus 100 plus 60. So this should be 260 upon 320 into 100, of course, percentage. So 260 upon 320 into 100 gives you 81.25 percentage, which is option D here. Then we have this question which says, okay, a wave moves along the surface of water. Diagram shows variation of displacement S with the distance along the wave at time t is equal to 0. Direction of travel is towards the right. Which graph best shows the variation with time t of the displacement S of the point P on the wave? Okay. So point P starts somewhere. What is on exactly left of the wave? If the wave is moving towards right, then point P is going to rise. Okay. So it starts at some point. So what should it look like? It starts at some point, then rises for some time, and then falls, right? And then obviously here there is a wave like this as well. So it falls further to complete this cycle, and this goes on, right? This is your main part. You should be focused here. Okay. So it starts at some point, then rises. This does not rise. This does not start at some point. This, it is rising, right? Not starting at negative. It is starting at positive. So option D is your answer. Then we have this another question. It is again about collisions. Should be again about velocities. Mass m1 traveling with speed u1 collides with mass m2 traveling with speed u2 in the same direction. After the collision, m1 has speed v1, m2 has speed v2 in the same direction. Collision is perfectly elastic. What equation is not correct? Okay. So let's form all the equations possible. Can I say half m1 u1 square plus half m2 u2 square is equal to half m1 v1 square plus half m2 v2 square? This is true because the kinetic energy before collision should be equal to kinetic energy after collision, as this is a perfectly elastic collision, right? If you cancel 1 by 2 everywhere, you get the, you don't get the required equation. Okay, v1, yes, if you transpose this here and this here, then you have m1 u1 square minus m1 v1 square is equal to m2 v2 square minus m2 u2 square. Is this the exact equation? Yes, it is. So this is a correct equation. Then you have just velocities. u2 plus v2 is equal to v1 plus u1. Now we had used this logic that if they are traveling like this, right, you just subtract the velocity. But collision can happen only if u1 is greater than u2. So I will subtract u1 minus u2 is your initial velocity of approach. And if the collision is not to happen again, then v1 has to be less than v2. Therefore, velocity of departure is v2 minus v1. These two should be equal, that u2 minus u1 minus u2 is equal to v2 minus v1. Okay, you have addition, so I can write v2 plus u2 is equal to u1 plus v1, which is the required equation. Then you have m into u1 minus v1 is equal to m2 into v2 minus u2. Okay, what does this suggest? This suggests that the change in momentum is equal. So for body m1, what is change in momentum? Initial momentum is m1 u1, final is m1 v1. So I'll write v1 minus u1 should be equal to m2 into v2 minus u2. Let's match this equation. Yes, this is the exact equation they are asking for. So obviously D must be incorrect, but let's see why is it incorrect. m1 into u1 minus v1 whole, oh, should not be whole square, right? It is square minus square, square minus square. You can definitely take m1 common here and m2 common here. So this is a slight mistake or incorrect equation mathematically, and that is why not your correct answer. Then you have a bicycle pedal is connected to a pivot by a metal bar as shown. Okay, 16, 20, 12, and force of 60 Newton. Force on the pedal is 60 Newton downwards. What is the moment of this force about the pivot? Now see, this is the direction of force. So what is the perpendicular distance? 16. So my moment must be 60 into 16 upon 100. Change it to meter. You have 0 zeros cancelled. 16 6 are 96 upon 10. 9.6 Newton meter. Yes, that is an option. So option B is your answer here. Now this question has been asked to me by my offline kids many times, and therefore I don't know if it's difficult for all of you or not here, but let's try this question. An elastic rod of unstretched length 16 centimeter, cross section 2.0 into 10 to the power minus 6 meter square, is held horizontally by two smooth pins at a distance 8 centimeter apart. The cord obeys Hooke's law. The load of mass 0.40 kg is suspended centrally on the cord. The angle between the two sides of the cord supporting the load is 60°. Okay, so this is the weight, right, which causes this tension, this elongation in the cord. What is Young's modulus of the cord material? We know that Young's modulus is equal to stress upon strain, which is equal to F by A upon delta L by L. Now area is given, L is given. Let's find delta L. See, this is 8, this should be 8, this is also 8. So the total is 24 and the original length is 16. So we have calculated this. Let's also calculate the force, the tension that is causing this stretching. Now if I want to draw a free body diagram, can I say W is the resultant tension, right? But because it is pulling the cord from both sides, so I can write here that it should be equal to the resultant tension. But let's find what that resultant tension is. Let's say this is T and this is also T. Because this is 60°, can I say the component of T here should be T cos theta? The component of this one is also T cos theta. So the total resultant is 2T cos theta. This is the stretching force. So weight is equal to 0.40 into 9.81. So 0.40 into 9.81 is 3.924 Newton. But this 3.924 Newton is equal to 2T cos 30. So 3.924 upon 2 into cos 30 should be equal to T. So divided by 2 cos 30 gives me 2.26 Newton as my tension. So let's quickly assume that here 2.26 upon 2.0 into 10 to the power minus 6 whole divided by 8 by 16, correct? So let's do that. So I have 2.26 upon 2.0 into 10 to the power minus 6 divided by 8. Okay, 8 upon 16. That gives me 226, 1, 2, 3, 4 zeros. 1, 2, 3, 4, 5, 6. So 2.26 into 10 to the power 6 Pascal, right? Because again, this is Newton per meter square. This is a unitless number. Okay. So 5.7, 1.1, 2. Yes. Option C is your answer here. Then we have this typical questions that they ask about waves. What is the phase difference in the wave? So let's do that. Two progressive waves meet at a fixed point P. The variation with time of displacement of each wave at point P is shown in the graph. Okay. What is the phase difference between the two waves? So first see, this is point P and this is also point P. But considering that they have constant phase difference throughout, right? I can find out any 2 points and then find out how much is the phase difference. So first I'll find what is the distance between them in terms of the time. So it is 0.3 seconds. For any wave, I can pick any wave and say that this time period of this wave is 0.8 seconds. Let's say this wave. Okay, this wave is also 0.8 seconds, right? This will not obviously change. So I'll simply write that if 0.8 seconds is 2 pi, right? In angle terms, it is 2 pi. So 0.3 seconds is how much? Simply 0.3 upon 0.8 into 2 pi. That will give me into 2. This gives me 135 degree, right? Which is your option C again. Then we have, let me zoom it out again. Microphone is connected to Y plates of cathode ray oscilloscope placed in front of a loudspeaker. The trace on the screen of CRO is shown time-based setting. What does time-based setting mean? It means that 1 centimeter on x-axis is equal to 0.5 milliseconds. And what does Y plate sensitivity mean? It means that on y-axis 1 centimeter is equal to 0.2 millivolt. Okay, so you have to just take that scale. What is the frequency of the sound from the loudspeaker and what is the amplitude of the trace? So let's find out. 1, 2, 3, 4, 5, 6. So this should be the center equilibrium. Okay, what is the amplitude? 1, 2 and 3 centimeter. If 1 centimeter is 0.2 millivolt, 3 centimeter should be equal to 0.6 millivolt, right? These two cannot be your answer. Then if 1 centimeter is 5 millisecond, then time period. So I'll find the time period as, okay, go from here 1, 2, 3, 4, 5 and 6. So 1 centimeter is 0.5 milliseconds, 6 centimeter should be 3 millisecond, right? 0.5 into 6 should be 3.0 millisecond. So 3.0 millisecond. Oh, we have to find frequency then. So frequency is 1 by time period, which is 1 upon 3 into 10 to the power minus 3. So 1 upon 3 into 10 to the power minus 3 gives me 333.33, which is 330 hertz and 0.6 millivolt of amplitude. Then we have this next question where it says, okay, think yes, where it says a trolley of mass 600 kilogram is initially at point P on a slope at a height of 80 meter above the ground level as shown. Trolley is released from rest and moves along the slope, first coming to rest at point Q at height h above the ground level. Total distance PQ moved by the trolley along the slope is 1.5 kilometer. A constant resistive force of 300 Newton opposes the motion of the trolley on the slope. What is H? So here it has a potential energy of 600 mgh basically. So m into 9.81 into height is 80. It does work of 1500 into 300, right, against friction. So let's find out what is the difference between these two, that is the energy remaining with this trolley. So 600 into 9.81 into 80, which will give me 470880, and here it will give me 1500 into 300, which will give me 45123 and 4 zeros. What is the difference? 470880 minus answer gives me 20880 joules of energy left, which will help it to climb at to this distance. So mgh should be equal to 20880. We know m and g. So h is equal to 20880 upon 600 into 9.81. 20880 divided by 600 divided by 9.81. So we have 3.54. That is the distance, or that is the height it can climb after doing this much work against friction. Then we have an object of weight 15 is pulled along a horizontal surface at a constant velocity of 2 meters per second. Force pulling the object is 12 Newton at 30 degree to the horizontal as shown. What is the power used to move the object? Okay, power is equal to force into velocity. Velocity is already given, so let's find out the force. As I've already told you, the component of this will be 12 cos 30. That is the force pulling this, right? There is no work done against weight. We're not lifting it, we're just moving it horizontally. So this will be 12 cos 30 multiplied by 2. So 24 into cos 30 should be equal to 12 root 3 or 20.78 power. So what? 20.78 can be rounded off to 20.8. Then we have this question: microwave in a vacuum travel at a speed x and have wavelength of order of magnitude y. What are the speed and a possible order of magnitude of wavelength of X rays in vacuum? Okay, so microwaves are traveling. Microwaves are longer waves with shorter frequency. If they travel at speed x, the order of magnitude of wavelength, speed should be x, right? It cannot change. All of them travel at same velocity. So this is not something you should be looking at. And wavelength of magnitude y. Now wavelength of X-rays is much smaller, right? And it is not just 10 to the power minus 4. It is much smaller. There is infrared, there is visible light, there is ultraviolet, right? And sorry, there is visible, there is ultraviolet and infrared, and beyond that you need to go, right? 10 to the power minus 8. So I believe A should be your answer. The wavelength should be in the order of 10 to the power minus 8 of the y. A mobile phone battery is charged by connecting it to a constant. I'm sorry, I should first. Yes. Now I think should be visible. A mobile phone battery is charged by connecting it to a constant potential difference of 5 volt. After a time of 1 hour, the initial current of 0.50 ampere slowly decreases to 0 as shown. What is the best estimate of energy transferred to the battery during the time of 2 hours? Energy transferred is equal to IV into T. I into t can be found out from the area of this graph, right? The whole thing. So it is a trapezium. So sum of parallel sides 2 plus 1. But because this is in hours, I require this in seconds. So 2 plus 1 into 60 into the current. The distance between them is 0.5, half into sum of parallel sides into distance between them. So one more half. So 3 into 3600 into 0.25, I think. So should be 3 into 3600 into 0.25 gives me 2700 multiplied by the constant voltage 5. So it gives me 13500 joules of energy, estimated energy. 13500 can be rounded off to 14,000. Then we have one more question from electricity. A potentiometer circuit is used. Okay, I should read it again. Potentiometer circuit is used to determine unknown electromotive force EMF of cell X in the circuit shown. E is the cell with EMF that is known accurately. QR is the potentiometer wire which has a movable contact S. Contact S is connected to a galvanometer and to cell X. What is not necessary requirement to determine EMF of X from the circuit? Okay, so what does this work on? The potential difference of QS will be equal to potential difference of this X, and this galvanometer will read 0 wherever it reads 0, because I know that this wire has a constant resistance per unit length. So I can quickly find out by just the ratio of the length. I can say this will be equal to X upon E. If this is known, this is known, this can be measured, I can easily find X, correct? Now let's see what is not necessary. The EMF of cell X must be lower than the EMF of cell E to determine X from the circuit. Okay, it should be lower, and we are finding a condition that is not necessary. Okay, the internal resistance of cell X must be known. Now see, if the resistance of QR is much higher, then you don't need to know the resistance of X. Okay, because I, if very small, I into R, the lost volts is going to be even smaller, right? And therefore it can be ignored. The lengths QS and QR must be determined accurately. So it is necessary. The resistance of the wire QR must be proportional to its length. Yes, it should be proportional to its length. So internal resistance, it is not necessary. So option B will be your answer here. Then we have uniform rigid beam of length 3.2 meter is pivoted at its center. Two children sit on the opposite sides of the beam as shown. One child is of mass 24, the other is of mass 36. The heavier child causes one end of the beam to permanently rest on the ground so that the beam makes an angle of 20 degree to the horizontal ground. What is the moment of weight of 24 kg child about the pivot? Okay, this is easy. I just see, because this is like this, right? I need to either find out the direction or the magnitude of this force in this direction, because weight is downwards like this. Or what I can do, I can find out this much distance and then multiply the weight. We have been given mass, right? So I'll say 24 multiplied by 9.81 is the weight. If this is 20 degree, can I say this is also 20 degree, and can I therefore find this one? If this is 1.6, can I find how much will this be, right? That has to be the cos multiplied by 1.6 cos 20, right? So that should be the moment of the weight. 24 into 9.81 multiplied by 1.6 cos 20 gives me 353.98 Newton. So 354, no, 350 Newton meter. Okay, so that should be your round of answer for this question. Then we have, okay, this is also similar question to what we already did, but it takes into account another property. When sound travels through air, air particles vibrate. Graph of displacement against time for a single air particle is shown. Which graph shows how the kinetic energy of air particle varies with time? Okay, so first we need to understand that whenever the particles are at extreme positions, their kinetic energy is zero because their velocity is zero. Any pendulum, see, if you can't imagine a particle, just any pendulum at its extreme position is about to come back. So it stops for some time, for very small amount of time at its extreme position, and at that time velocity is zero. If I say velocity is equal to 0, then kinetic energy should also be 0. So kinetic energy 0 at the start, kinetic energy 0 at t is equal to 0, kinetic energy 0 at 2t, and once it is 0 between all of these times. So kinetic energy not 0 at start, kinetic energy 0 at start, kinetic energy not 0 between somewhere here at 0, 0, okay? But this cannot be your answer. Kinetic energy is non-zero at start, kinetic energy is 0 at start, somewhere in between, at t again in between, and again at 2t. So D is your correct answer. Then we have this nice question. We have stationary sound waves can be formed in the air column of pipes. One type of pipe is closed at one end and open at other end. Another type of pipe is open at both ends, which pipe can form a stationary wave with lowest frequency. Now, considering the velocity of the wave is same, right? Sound wave, the velocity of sound wave in pipes is same. For lowest frequency, V is equal to F lambda. For lowest frequency, the wavelength has to be highest. Now, if it is an open pipe, then the first harmonic, the first harmonic must be like this. So your 2L has to be lambda by 2. This is half the wavelength, right? 1/4 here, 1/4 here. But here the first harmonic forms like this. So your 2L should be equal to lambda by 4, and then lambda is equal to 8L. Here lambda is equal to 4L, right? Let's see what happens here. Here I can use same logic, but L is equal to lambda by 4, so lambda is equal to 2L, and same logic for this one here, but L is equal to lambda by 4 instead of 2L, so 4L is equal to lambda. Here the longest wavelength is this particular option, so B is your answer. Then we have question 41. It says some particles are combination of three quarks. Which combination does not result in a particle with a charge of either plus 1.6 into 10 to the power minus 19 or 0? So up, down, down. That is obviously 0, right? Up, strange, strange, 0. Up, up, down. So 2 by 3 plus 2 by 3 minus 1 by 3. See, you need to remember up, the charge on up, down, strange, charm, then anti-up, anti-down, anti-strange, anti-charm. I think the symbol for this is incorrect, but yes, at least these many you need to remember. Okay, so not a particle with either charge, so this will be 4 by 3 minus 1 by 3, which is equal to 3 by 3, which is equal to plus 1, which is 1.6 into 10 to the power minus 19. So that is your condition, so it's okay. Up, up, up will be 2 by 3 plus 2 by 3 plus 2 by 3. This will neither be the option. So option D is your answer. Okay. Also up, down, down, that's your neutron, and this is your proton. Then this is the last question for today. Okay. No, there are two questions. Okay. First one says charge to mass ratio R of a particle is given by the equation shown. The value of R is decided for an determined for an alpha particle, beta particle, and proton. Which list shows particles in increasing magnitude of r from left to right? So let's write r for alpha particle is equal to charge on particle. So I'll write relative charge first. If need be, we will add the actual charge as well. So relative charge is plus 2. Mass of the particle, it is 4 times the mass of a proton, right? Then r for beta plus particle, it has a charge of -1. I think they are talking about magnitude only, right? Yes. So you don't need to write this plus or minus actually. So 1 upon the mass. Okay. So that is mass of an electron. Mass of an electron is averagely mass of proton divided by 1340 something. Okay. Then R for proton is equal to 1 upon mass of one proton. Now if you make it equal, I can write this as 1 by 2 p. This is 1340 by p, and this is 1 by p. Okay. So from left to right in increasing magnitude, increasing. So the lowest one first. So 1 by 2 p, right? Sorry, 1 by 2 p, 1 by p, and 1340. See, in your exam you will have the exact value for the mass of an electron, exact value for the mass of a proton, so you can use those values. But here I can simply even just round it off because exact answer is not required. What is this? This is your alpha particle, then this is your proton, and this is beta plus. So alpha, proton and beta plus is option B. Which combination of up and down quark forms a neutron? I just told you, up down down is neutron. So up down down, option C is your answer. With this we have finished the doubts that a lot of kids ask me, but you have some time. This video will be up 2 days before your exam, so you can drop in comments the questions, just the paper number and the question number. I'll try to explain. If there are a lot of doubts, I will make another video, or I may come live just the day before exam. Until then, keep practicing and all the best for your exam. Bye bye.